Hello students, I am Purwar and I welcome you all in this tutorial. Today I am going to discuss a very important question that is also related to Young's double slit experiment by YDSE. And I am assuming that you understand the basics of YDSE. If not, then you can watch my video on YDSE. I will put the link in the description. Okay. So let's understand today's question. Let's solve the question. Let's move to the screen. So the question is, white coherent light 400 nanometer to 700 nanometer is sent through a slit of Young's double slit experiment. The separation between the slits is 0.5 mm and the screen is 50 centimeter away from the slits. There is a hole in the screen at point P 1 mm away from the center line. So see this diagram. This is the diagram. These are two slits S1 and S2. A white light has been sent like this. Okay. And this is a point P where hole has been created at the screen. This is a screen. Okay. Okay. The distance of slits to screen is 50 centimeters. That's right. That is given here. Okay, and a separation between the slits is also given, that is 0.5 mm. Okay, that is also given, and the distance of hole from the central maximum is also given, that is 1 mm, 1 millimeter. Okay, okay. So in this question there are two parts. In the first part, what is asked? It is asked which wavelength will be absent in the light passing through the hole. When the light will come at this point, they will interfere. Okay. So the question is, which light will be absent? Means if that light absent means the minima of that light should be formed at this point, means the dark fringe should be formed. If the dark fringe will be formed, then minima will be there, means zero intensity will be there. If zero intensity will be there, then that light will be absent. That is what is asked, that which wavelength will be absent in the light passing through the hole. Getting the point, right? So if at the point dark fringe has been formed corresponding to one wavelength or another wavelength, that one wavelength or another wavelength will be absent at the point P. Okay. So first question you are understanding. First understand the question. Okay. Then we will solve the question. And in the second question, which wavelength will have a strong intensity? So strong intensity means maximum intensity, right? So maximum intensity means bright fringe should be formed, right? So we have to see at point P corresponding to which wavelength maximum intensity is getting formed. Okay, those wavelengths will have strong intensity. Okay, so what we have to see at the point P, we have to see corresponding to which wavelength dark fringe will be formed and corresponding to which wavelength bright fringe will be formed. This is the whole question. Okay, so question is not very tough, but the language of question can be tricky. So now I hope you have understand the question. Now let's solve the question. Okay. So the solution. Now first let's see what the quantities are given. So given capital D is given, that is 50 centimeters. Let's convert it into meter, so that will be 0.5 meter, and small d is also given, that is 0.5 mm. Let's convert this also in meter, so that will be 0.5 into 10 to the power minus 3 meter, and by n is also given, that is from mm, so that will be 10 to the power minus 3 meter. Okay, yeah. So first let's solve part A. Okay, yeah. So in the part A, we have to check corresponding to which wavelength dark fringe will get formed. So condition for dark fringe. Condition for dark fringe. It is d sin theta is equal to n plus half lambda, right? Yes. So d and sin theta can be written as yn divided by capital D is equal to n plus half lambda. Okay. So let's put all these value of d by n and capital D. So D is 0.5 into 10 to the power minus 3 by N is 10 to the power minus 3 divided by capital D is 0.5, right? And N, and I can write it 2N plus 1 divided by 2 into lambda, right? So 0.5, 0.5 will get cancelled out. That we will be left with 10 to the power minus 6 is equal to 2N plus 1 divided by 2 into lambda. So let's write this expression in terms of lambda. So lambda is equal to 2 into 10 to the power minus 6 divided by 2N plus 1. Okay. Okay. So we have to calculate the value of lambda corresponding to which dark fringe will be formed. Right. So we know N can be equal to 0, 1, 2, 3 dot dot dot. Right. So for N is equal to 0, let's calculate the wavelength. So I am calling this wavelength lambda 0. So that will be 2 into 10 to the power minus 6 divided by 2 into 0 plus 1. So it will be 2 into 10 to the power minus 6. Right? Right. So it is in meter. Let's convert this into nanometer. So that will become 2000 nanometer. Okay. Why I am converting this into nanometer? Because the white light range is given in the nanometer, that is 400 to 700 nanometer. Okay. Okay. So now let's calculate it for N is equal to 1, and let's see what is the value of lambda. So I am calling this lambda 1. So that will be 2 into 10 to the power minus 6 divided by 3. Right. So it will be again 2000 divided by 3 nanometers, right? So if I will multiply, then this will be 667.7 nanometer approximately, right? Right. Now calculate for N is equal to 2, right? So that will be lambda 2 is equal to 2 into 10 to the power minus 6 divided by 5, right? So this will be 2000 divided by 5 nanometer, or I can write it 400 nanometer. Okay. Now let's calculate for N is equal to 3, right? So I am calling this lambda 3, and that will be 2 into 10 to the power minus 6 divided by 7, right? So it will again be 2000 divided by 7. So it will come out approximately 300, approximately 300, right? So 300 nanometer. So from the range of white light, that is 400 to 700 nanometer, which wavelengths are falling in this range? Tell me. See, for N equal to 0, the wavelength is 2000 nanometer, that is not falling in this range, right? For N is equal to 1, the wavelength is 667.7 nanometer, that is purely falling in this range, right? And for N equal to 2, the wavelength is 400 nanometer, that is again falling in this range. But N equal to 3, the wavelength is 300 nanometer, that is not falling in the wavelength. So only 2 wavelengths are falling in this range, that is lambda is equal to 400 nanometer and 667.7 nanometer. Okay, so corresponding these 2 wavelengths, only dark fringe will be formed, means minimum intensity will be there, means zero intensity will be there, means corresponding to these 2 wavelengths, the light will be absent. Okay, whatever light, what color light will have corresponding to these wavelengths, that light will be absent at that point P. Got this point? Right. So I will putting this in the bracket that these 2 wavelengths will be absent. Okay. Right. So this is your answer. Right. Now let's solve the part B. Similarly, we have to solve the part B. There is nothing new in part B. In the part B, we have to see the condition for bright fringe. Condition for bright fringe. What is the condition for bright fringe? That is d sin theta is equal to n lambda, right? Again, we can write sin theta is equal to yn divided by capital D is equal to n lambda. Again, put all these values. So these we have calculated. So this will be same. What was its value? Its value was 10 to the power minus 6, right? So I will put directly 10 to the power minus 2 because we have calculated this in the previous case. Okay, n lambda. So lambda will be equal to 10 to the power minus 6 divided by n. Okay. Again, for we know n is equal to 0, 1, 2, 3, dot dot dot. So we know for n equal to 0, it will be undefined, so we will not for. But for n is equal to 1, we can calculate. So for n is equal to 1, lambda 1 will be is equal to 10 to the power minus 6 divided by 1 meter. So this will be 1000 nanometer, right? For n is equal to 2, it will be lambda 2 is equal to 10 to the power minus 6 divided by 2. So it will be 500 nanometers, right? Similarly, for n is equal to 3, lambda 3 is equal to 10 to the power minus 6 divided by 3. So it will be 1000 divided by 3. So it will be approximately 333.3 nanometer, right? Now, what is the range of white light? The range of white light is 400 to 700 nanometer, right? So tell me which wavelength is falling in this range. Only 500 nanometer is falling in this range. 1000 is not in this range. 330.3 is not in this range. So lambda is equal to 500 nanometer is falling in this range. What does that mean? It means that corresponding to this wavelength, corresponding to 500 nanometer at point P, bright fringe is getting formed. Means corresponding to this wavelength, we are getting maximum intensity at point P. Okay. So I am putting this lambda is equal to 500 nanometer into bracket. So this is your answer. Okay. I hope you have understood this question. Thank you. Bye bye.